In this video, we'll look at the law of sines. So we'll first start with talking generally about how to solve a triangle, what information we need to know in order to solve a triangle. We'll look at a couple of those cases, and then a subset of those cases will require the law of sines, which we will then talk about, do a quick derivation of, and talk about a specific case that we need to be careful about when we use the law of sines. So in general, to solve a triangle, we need to know certain information about sides and angles. It's almost always helpful to draw a picture. So we could be given two angles and a side. We could be given two sides and an angle. So let's look at a couple different combinations of angles and sides that we could be given. For example, perhaps a really easy one to start with is if we're given two angles and a side in between those two angles. So here's a side. I'll draw some dashes there, some dashes there. And here are the two angles. So we call this side A, and the two angles big A and big B. Obviously, if we continue to draw the dashes, eventually those two sides will meet. So if we're given two angles and an included side, we obviously have something that defines a triangle. It uniquely defines a triangle. So now suppose we have a side like this, an angle here, and then another side opposite that angle. It's clear that this does define a triangle. But the problem now is that we could actually swing this side B. We could swing that side inwards and have the same length. You can kind of see how that works, right? It actually creates kind of an isosceles triangle. And this is the ambiguous case. We'll talk about this more later on. Another case, we could be given two sides and an included angle. Like this, we can have A and B and A. And sometimes we may be given all three sides in a triangle. Now, some of these are more difficult to solve than others. In particular, the first case here, we'll call this case 1, typically called angle, side, angle, because we have an angle, an included side in between two angles. Case 2, we have two sides, one of the sides being opposite an angle that we're given. So this would be side-side angle. Case 3, we have a side, an included angle, and a side. And case 4, we have three sides. The first two we can solve using the law of sines, and the second two we must use the law of cosines. So we'll get to that in the next video. So the law of sines. In triangle ABC, we have sine of angle A over little a, sine of angle B over little b, and sine of angle C over little c. To see why this is true, let's just remember, drop that down there, get a right angle. So recall from before that the area of a triangle is 1/2 AB sine theta, where A and B are two sides in a triangle and theta is the included angle. Of course, if we're given multiple sides and multiple angles, we could define the area equivalently using different combinations of the sides and angles. So we could say that 1/2 AB sine C equals 1/2 AC sine B equals 1/2 BC sine A. And if we just multiply through by 2 for every set of equal sign, and then divide through each part in the equal signs by A, B, C, we'll get something very clean. So we'll multiply by 2 over A, B, C, 1/2 A, B sine C equals 2 over A, B, C, 1/2 AC sine B equals 2 over ABC times 1/2 BC sine A. So the 2's and the 1/2's cancel out in each case, and then everything but the side opposite of the angle is canceled out. So we have sine C over little c equals sine B over little b equals sine A over little a. Now to look a little bit more deeply at one of the specific cases that I mentioned before, the side-side angle case. So I've drawn up a couple schema here so we can talk about it a little bit. So we're given the angle A and we're given the side B. We're also given a side A, given little a. Now I just want to kind of postulate at different lengths of this side. So in case 1 here, in this incomplete triangle 1, if A is too short, we can't swing it one way or another to create a triangle based on the length of B and the angle that we currently have. So that case, we're not going to have a triangle. Let's look at another one. We could have a length that just goes straight down and creates a right angle. So if A is just the right length, it'll drop down and we'll have a right triangle with angle A, side little b, and side little a. If the length of A is a little bit longer, then we can actually kind of sweep out this length like this. So there are 2 solutions for one given side length. This third case is an interesting one, so when we start to solve problems with that, we need to be very careful. And then with side C, if we continue to lengthen out, and then in this fourth case, if we continue to lengthen out side A, eventually there will only be one solution. We could swing this out and we wouldn't come back in contact with the triangle. So we start with a short length that does not create a triangle. We lengthen it out so it just hits the bottom and we create a triangle that happens to be a right triangle. If we continue to lengthen out the side A, we can kind of sweep through 2 possible triangles created with that length A. Or if we continue to lengthen out A, there's a point at which we only get one possible triangle given the information that we have. In the next video, I'll look at a couple of different cases so we can have an idea on how to identify what kind of triangle we're working with, and then how to solve for all the sides and angles in that particular triangle.